بسم الله الرحمن الرحيم رب زدني علما.
Now, the next thing we'll try to understand about the CAPWAP tunnels. Now, CAPWAP stands for Control and Provisioning Wireless Access Points. In the previous section, we have discussed the authentication, the basically how the access point is going to bind with the WLC, with the discovery process, where every access point is going to discover and establish a connection with an access point. So, and again, it is going to build a tunnel, and we call this as CAPWAP tunnels. Now, these CAPWAP tunnels are responsible for encapsulating the user traffic. I'll talk about that. Similar way, every access point is going to build a CAPWAP tunnel where the actual traffic is encapsulated as it moves through the network. Now, once the client, the access point, is going to discover with the WLC, and once it finishes the authentication process, it's going to build the CAPWAP tunnel. So this is your CAPWAP tunnel. And likewise, when you have multiple access points, so all the access points are going to build the same thing. So they are going to build something called CAPWAP tunnels. Now this WLC is going to become the central hub that is going to support multiple access points which are scattered in your network. So maybe you have hundreds of access points or thousands of access points. So every access point has to build a CAPWAP tunnel that's something established. The CAPWAP tunnel is established after they both discover and join with each other. Now, what exactly these CAPWAP tunnels will do? Again, the two devices. Now, two devices means here the access point and the WLC. Now, these two devices, they build the CAPWAP tunnels. That is your tunneling protocol. CAPWAP is a tunneling protocol which is going to carry the 802.11 related messages and the client data. So as I said, it is going to encapsulate the data between the access point and the WLC within the IP packets. Now, how exactly it is going to be? Like, let's say this is a wireless client. Now, this wireless client is going to connect to the access point. And now this access point already established a CAPWAP tunnel. So there is a CAPWAP tunnel which is being established once they discover and join with each other. And now this WLC is going to receive the information. So now what happens is this access point is going to encapsulate all the data, whatever the user traffic we can say. So this is going to be encapsulated inside this CAPWAP tunnel, and it is being sent to the WLC. Now once it reaches the WLC, now the WLC is going to unencapsulate or remove the encapsulation. Whatever the CAPWAP encapsulation is going to remove it, and then depending upon it is going to examine the particular frame, identify the device based on the MAC address, the same like normal switching, and it's going to identify the VLAN and then forward over the trunk link to the respective VLAN it is supposed to reach, and based on that it will reach a specific destination. Let's say this is my destination. Now again the same thing happens when the packet is returning back, so it will go again the same way, and there will be a CAPWAP tunnel established here between them. The same thing reaches to the WLC. So when it is returning, it is like kind of reverse. So again, the WLC is going to tunnel or encapsulate back to the access point, and then it reaches back to the end client again. So that's what happens. So basically, this is a backend process where it's going to use something called CAPWAP tunnel, and inside this tunnel, all the user traffic is encapsulated between this. So it includes all 802.11 related messages and the client data. Now again, as the network grows, like I said, as the more access points you have, so let's say these are all my access points. So every access point is going to build a centralized CAPWAP tunnels. Like every access point have a separate tunnel is being established between the access points and the WLC. So again, WLC is like a central hub, act as a central hub connecting to all the access points. Now again, one more thing, like SSIDs can exist on each and every access point, which means, let's say you may have a VLAN 100 user is configured with SSID, let's say 100, and you want the users of this SSID 100 to talk to the SSID 100 on the different access point. Now, how it works, again, the same thing. It's the access point is going to encapsulate inside the tunnel, and then the WLC is going to de-encapsulate or remove the encapsulation, and then check the VLAN ID and then send it back to the switch, and from there to the switch, and then reaches to the nearest access point and then back to the end device. So this is the same typical process what I discussed. And one more thing we need to remember, whatever the access point you're using, let's say this access point and the WLC need not to be directly connected. Means the access point and WLC may be in different, far from each other, no direct connection. Because if you see the topology, I do have multiple switches connected here. And technically these two can be on the same net, same subnet. Like this can be on 10.1.1.1 and this can be on 10.1.1.2. Or it can be on different subnet. Like maybe this is 192.168.1.1 present on a different VLAN, different network. So that doesn't matter. So as long as you have reachability between the access point and the WLC, we can still establish the CAPWAP tunnels. So that's what the AP and the WLC need not to be on the same subnet. So they can be on the same subnet or they can be still on different subnets. So it's like not compulsory to be on the same subnets.